Hello, this lesson is on differentiating and integrating natural, exponential, and logarithmic functions. Or in other words, this might be a little bit of a review, but we're going to try to differentiate, integrate, or antiderive e and ln functions. So very basic. Like with all these videos, we're trying to keep it short and keeping it to topics that I think you'd understand, e and ln. So first of all, if I scroll down here, if you want to take the derivative of e of x, we've studied this before. As a review, the derivative of e of x is e of x. So if I had to do these examples, for example, this one says 3e to the x. The derivative of 3e to the x is 3e to the x. Okay. If I have something like this, where I have a function inside, I have to take the derivative of the inside also by chain rule. So derivative of the outside is e negative 3 to the x times the derivative of the inside, which is times negative 3. So this becomes negative 3e to negative 3x. So again, anytime you have a case where I have a function inside of the e, I have to multiply by the derivative of the inside. In this last one, you may notice that I'm multiplying between two quantities. One is e x squared, and another one is square root of x, so I have to do product rule. The derivative of the, if you forgot product rule, so the derivative of the first one, leave the second one alone, plus derivative, leave the first one alone, times the derivative of the second one. So what I'm going to do is I'm going to take the derivative of the first one. In this case, it's e x squared. Again, I have a function inside of e, so it's going to be derivative of the outside, which is e to the x squared, just itself, times the derivative of the inside, which is 2x. So I'll do that. Leave the inside alone. Plus, leave the first one alone. Times the derivative of the second one. You should already know by now that the square root of x is the same thing as x to the half. So the derivative is half x to the negative half. And that's the derivative of that one. So that's review. Should be very easy. Hopefully you understand that one. On the bottom it says integrating. This one's kind of new, but it's the exact same thing. If you take the antiderivative of e to the x, it is also e to the x. In these cases, there's no product rule and there's no chain rule. You just know that there might be possibilities where you have to do u substitution. So in this first one, I have 6e to the x. I could remove the 6 or factor out the 6, like so. And now I just have the antiderivative of e to the x dx, which that is just e to the x plus c. In the second one, you'll notice that, one step more difficult. I have a function within a function, but there is no chain rule for antiderivatives. There's only u substitution. So in this particular case, I'm going to say u is x squared, which makes du 2x dx. Okay? And you may notice in this problem, I have a 2x dx, but my problem has a 3x dx. Okay? So what I'm going to do, I'm going to do two things. One, I could factor out this 3, just like we did in the last problem, so this disappears, and I just have an x dx, which means on this du problem, I'm going to say, I'm going to divide both sides by 2. Half du equals x dx. And now I have a good substitution. If I rewrite the problem, I have that 3 on the outside. I have an x dx, which turns into half du, and this becomes e to the u. So again, that x squared turns into u. That's how I got this. And then my x dx turns into half du. Okay. Now this should be very simple. I could factor out the half. This becomes 3 over 2. E to the u du. And you know the antiderivative of e to the u is e to the u. And plus c. And the problem didn't have u. The problem had x's. So at the end of this, I'm going to have to put the x's back in. This becomes 3 over 2 e to the x squared plus c. Okay, still very simple, still kind of review. And the last one, same thing, except for this one, you'll notice that now I have bounds. Okay, so you may be wondering, how does that change everything? Just to review, again, this one has a function within a function. I have an x squared minus 1 inside of e. So I'm going to call u x squared minus 1. I'll call du 2x dx. In this particular problem, you may notice I have an x dx. So I have to change my bottom equation into an x dx. So this becomes half du equals x dx. Okay. Now, if you remember, because this has bounds, because I have a 1 and a 2, I have to change those bounds also when I do the u substitution. If you forgot, if you remember, to change these bounds, I plug that into my u equation. So I'll put 1 and 2 in for x, and it'll give me the new u. If I plug 1 into here, I get 1 squared minus 1 and that becomes 0. So my new integral now becomes 0. Because again, I put in 1 for x, I get 1 squared minus 1 is 0. Then I put 2 into this equation. Oops. I put 2 in for x. I get 4. 2 squared is 4. 4 minus 1 is 3. So my new bounds are 0 to 3. This now becomes, if you remember, e to the u, because that x squared minus 1 becomes u, and x dx becomes half du. I could factor out a half, like so, right? And then the antiderivative of e to the u is e to the u. So this becomes half e to the u, 0 and 3. I plug in 3, I plug in 0, and I subtract the two quantities. So my answer is going to be half e to the third minus e to the 0. You should know e to the 0 is 1, so you can simplify this even further. But if you want to, you could stop right there. Okay, so that's all you need to know about e's. E's are very easy because the antiderivative and derivative is itself. It's the only quantity you'll learn in calculus where it's like that. Now, if you go to the next page, ln is a little bit different. If you remember, ln, the derivative of ln is 1 over x, and so that's that. So let's do the derivatives of ln. Same thing, there's a chain rule here. I have an outside function and I have an inside function. The derivative of the outside, the derivative of ln, is going to be 1 over x to the third, because I have ln x to the third, so it's 1 over x to the third. Times the derivative of the inside, my inside function is x to the third, so it's going to be times 3x squared, or it'll be 3x squared over x to the third, or it'll be 3 over x. That's how you do ln problems. A little more difficult here. You may notice that I have a 5 ln x to the third power. In this particular case, I could use a chain rule again. Here I have a power rule. I have a 3 up here. And on my inside function is ln x. Okay. So what I'll do is I'll do the outside times the derivative of the inside. If I do the outside function, I'll do power rule. This becomes 15 ln x squared. So hopefully you see the power rule. 5 times 3, then I subtract 1. Times the derivative of the inside. The derivative of the inside is ln x, which is 1 over x. Or, to simplify this, 15 ln x squared over x. Okay. And then let's just do one more, to see if you understand it. In this one, I have a function, ln, who has sine inside of it, which has ex inside of it. So now I've got a chain rule, something inside of that. Okay, so I'll take the derivative of the outside first. My outsidemost function is ln. So this is my outsidemost function. So it's going to be 1 over sine e to the x. Right? So the outside function first. Times the derivative of the inside function. The next inside function is sine. So the derivative of that is cosine e to the x. Leave the inside alone. And the derivative of the inside of that, e to the x, derivative of e to the x is e to the x. So if I simplify this, the whole thing, it becomes e to the x cosine e to the x over sine e to the x. So that's that. Hopefully you understand ln. ln, the derivative is actually 1 over x, or if you do chain rule, it's going to be 1 over what's inside of it. So in this last example, it was 1 over sine e to the x. In the first example, it was 1 over x to the third. So ln, its derivative is 1 over whatever's on the inside. So we're going to skip over to, that's it. So that's that. Hopefully you understand ln and e, not to be very difficult. But if you have any questions, remember to ask in the questions, and hope you enjoyed the video, and I'll see y'all later.